So, of course, I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're discussing 5 tips that can help you design faster in Onshape. And so, what we thought we'd do is put together a webinar that can help the users, some of the more experienced users that are looking for easy ways to speed up day-to-day tasks, tedious things they may be doing in Onshape. So, 5 tips for designing faster in Onshape. As I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address the questions as we're going through today's webinar. I also have a few questions to ask of the audience, so bear with me in just a bit. I will ask those as well. But again, we like to make these as interactive as possible, so feel free to ask any questions as we're going through this. And it's going to be a fast webinar. We're really just going to focus on these 5 tips. And I think, again, these aren't things that are going to drastically overhaul how you work day to day. There are little things that can mean big improvements collectively when you start to consider them over time. So just little things that you can do in Onshape that can really speed up day-to-day work. That's really what I was hoping for with this webinar. All right, so let's get into it. Now, the agenda is really simple. We're going to walk through 5 tips to help you design faster. So no secret agenda here. We're just going to go through 5 different tips. As I mentioned before, I'm going to answer any questions that you'd like. So feel free to ask any questions in that questions section of your GoToWebinar control panel. Now, before we actually get into tip number 5, and we're going to do this in a countdown style. We're going to start with number 5 and work our way to number 1. I'd like to ask a question of the audience. So if you would bear with me for just a moment, I'm always interested in the audience, and what kind of audience is listening, and are you interested in Onshape for professional use? Are you using Onshape today for professional use? Are you using Onshape today as a hobbyist? It really helps me to tailor the presentation towards that particular group. So if you would take just a moment to answer, and then we'll move on here. All right, looks like the majority of the audience is either using Onshape for professional use or considering it, so that's awesome. So let's close things out here, and let's jump back. Now, what I'd like to do is get started. As I mentioned before, I want to get started with tip number 5, and we're going to work our way from tip number 5 down to tip number 1. Now, let's jump right into it. Tip number 5, final. As I mentioned before, these are all little things that can make a big difference, and what we've tried to do with final is eliminate a lot of the back and forth between sketch and feature. And this is one of those features that's really underused. Not a lot of users use this, and it has the ability to save you a lot of time. Now, if you find yourself editing a sketch, accepting the sketch, rebuilding it, taking a look, going back, editing a sketch, and you find yourself in this vicious cycle of making constant changes and seeing the end result, final is a huge thing. And what it allows you to do is essentially see the finished model as you're sketching. And the big thing there is you can make changes to the sketch and instantly see their impact on the finished design. And the reason that's so big is if you find yourself doing a lot of trial and error design where you're testing things out and changing dimensions and see what they look like, this can be a great way to change dimensions and not have to go back and forth between the sketch and the feature. So again, all you're really saving yourself, you find yourself edit sketch, change it, rebuild it, edit sketch, change it, rebuild it in this loop, this can make a big difference. So let me show you how this works. Now, final is a real simple thing. Any sketch that's been used to create a feature, you'll have the final option. And an example I like to give is a loft, but you can use this in any sketch that has a feature. Extrude, revolve, sweep, loft, it doesn't matter. So in this example, I have a squeegee, and I have a loft between the handle of the squeegee and the base, and the loft is controlled by these guides. Right? So if we roll up just above the loft here, you'll see these guide sketches are what's driving the loft contours. Now, this is something I may not get perfectly right the first time, and I may want to manipulate it later on. So here's an example. I wanted to make a modification. Let's say that I'm not comfortable with this guide. I wanted a little bit smoother transition. Right? I can right-click and edit the sketch. Of course, the feature then disappears. And what a lot of users will do is they'll say, okay, let's make my modification. I'll hit the green check. We'll let everything rebuild. I look at it. I still don't like it. Okay, we'll go back, right click, edit sketch. We'll make another change. Maybe I'm a little too far. Right, green check, rebuild. So I think you get the idea. As I'm making these changes, they may be subtle changes, they may be, big changes to my sketch. I find myself constantly hitting OK, rebuilding, editing the sketch, hitting OK, rebuilding, and just, constantly going through this loop process. So the idea behind Final is really simple. In that sketch, in the sketch dialog, you'll see a button called Final. And all it does is it gives you the finished model live. And the beauty of it is, as you make your design changes, if I grab and drag, for instance, let's pull this down, you'll see the loft dynamically updates, right? So I don't have to hit the green check, rebuild the model, see what it looks like, go back and edit the sketch and do this over and over and over again. I can just make my simple changes in the sketch with Final on, and it will rebuild live. So just a big tip, if you find yourself doing a lot of that, kind of trial and error changes to your sketches, subtle things that you may want to see update live, you can do that. And again, any sketch that's used in a feature, you'll see the Final button. So I hit the green check, and there we go. But the idea is just allowing you to make those subtle changes, see the finished result live without having to go back and forth. So tip number 5 is Final. Definitely something you should consider, especially if you find yourself going back and forth between sketch and feature a lot. Again, you'll find it in the bottom left corner of the sketch dialog. So while you're in a sketch, you'll see it in the sketch dialog. And the idea is just saving you from going back and forth. So that's tip number 5. The next one in my list is mate connectors. So the key thing with mate connectors is really understanding them. And I think for a lot of users, this is one of the things that they can easily get hung up on, especially if you've come from a more traditional CAD system, a SolidWorks or an Inventor or a Creo or one of those types of CAD systems that may do it a bit different. So what I want to do here is mention 2 things, just understanding the mate connector process and how it can be faster for assemblies, but also the ability to add custom mate connectors and save even more time with custom mate connectors and snapping parts into position. So this is an area, if you're looking for a way to speed up assembly design, where you can really save a lot of time, especially if you find yourself doing a lot of redundant tasks, constantly mating a certain part into a certain position. Custom mate connectors and using mate connectors properly can make a big difference. So let me show you what we've seen a lot of and what we think is the better alternative. And what I have here is 2 assemblies and what I call good and bad techniques. The first that I want to mention is the bad technique. And I call it the bad technique, but you might call it the old school technique or the SolidWorks, Inventor, Creo type of way. It is a bit different. So what I want to do is show you, that you can do it the way that you're used to. If you've come from a traditional CAD system, you can work that way. But there's not a lot of advantages to it. It's a much slower approach. Let me show you what I mean. Here we have the swing arm on the top of our plunger. And if you can see, I have it mated correctly into place. However, to mate it into place, it took 3 different mates, right? This is just, again, using question. If anyone else is having any audio issues, let me know in the chat. Okay, so what I'd like to do is walk you through how a new user might do this and the mistakes and things that can happen from it, okay? So let's go through and delete these 3 mates, right? So we'll delete those 3 mates. We'll move our swing arm over. Now, a new user may have this workflow, and it's an easy adaptation if you come from another CAD system. I want first some kind of concentricity between the plunger and the swing arm. I would use maybe something like a cylindrical mate that will give me that concentricity. All right, and I'm just choosing any points on there. Again, this is what I would refer to as the bad technique. So now I have my concentricity. In a traditional CAD system, step 1 of 3, right? Now I need some kind of mate that brings the 2 flat faces together. In this case, we could use a planar mate, right? So I can select face, end face, and it would bring those two together. Now I've got the second mate that attaches the top faces together, but I still need something that keeps it from rotating relative to the plunger. And oftentimes in a more traditional CAD system, you might use something like a parallel, right? We've got that as well, parallel between this face and maybe, this face. And the idea behind it is just that you're, controlling the degrees of freedom one at a time. So now, it can't go left or right. If I add that cylindrical, then I add a planar and, brings the two together, but it does it in 3 separate steps. And this is one of the more common mistakes that we'll see from new users coming in, or even experienced users who have a lot of experience in other CAD systems will model this way. And the natural downside of this, of course, is that you have 3 mates that you have to troubleshoot if there's a problem. You have 3 mates that you have to fix if there's a design change, and if you have something drastic happen where the mates break. So just keep in mind it's less to troubleshoot, less to rebuild, and so on. Now, how would you accomplish the same thing in Onshape? And the thing that I would stress is understanding the mate connector and not using a combination of faces. So the way to think of a mate connector is a point, a connection point between parts. So if you think of these 2 parts, there's a connection point at the top of this hole, and there's a connection point at the top of this plunger. So the key thing to keep in mind here is I just want to bring those 2 points together and fix them, right? This doesn't need to move in any direction. And in this simple example, that can be done with one fasten mate, right? So I select fasten, I choose that connection point at the top of the swing arm, the connection point at the top of the plunger. We refer to them as mate connectors, and it brings those 2 together. Green check, and now that one mate controls the orientation, the position of that part, right? So again, just driving home, if you get used to mate connectors and the approach of using mate connectors for your assemblies, you can go from, in this bad example, using something like 3 different mates to position one part, to the good example where it's just one fasten mate. Now, taking this to the utmost extreme, you can even build your own custom mate connectors. And I think the biggest benefit of this is just you find yourself, constantly positioning a part at a certain angle value, or it's always upside down and I need to flip it every time I create this mate. And if you do that with a lot of standard library parts, it makes sense just to add a mate connector at the part. Define yourself as part of the design intent, the part's connection point to wherever it's going into the assembly. So I'd like to show you an example of this and one big benefit to it. So here I have a pneumatic cylinder. Let's jump into a finished version of it so you can kind of see what it looks like. So here's a pneumatic cylinder. And, maybe I need to assemble end caps or different pieces of it. So let's jump into the Parts Studio. And what I'd like to point out is defining mate connectors in the Parts Studio like this has a big advantage at the assembly level. So let me scroll down just a bit. If you're not familiar with it, you can create a mate connector right here in the toolbar, and then assign it to any geometry of any part that you'd like. So in this case, you'll see I've got mate connectors at the ends of these end caps. And that point is the attachment point between my end cap and the cylinder for this particular assembly. So what I've done is I've defined my mate connector, my predetermined attachment point at the Parts Studio. Now you may ask, well, Onshape is automatically finding these mate connectors. Why do you need to do that? You don't have to, but there's one big benefit that I always like to stress with this, and this is especially big if you do a lot of placement of tedious parts. I'm positioning dozens of the same part over and over and over again, and that is snap mode while inserting. So when you're inserting parts into your assembly, you can actually turn on snap mode. And the beauty of this is it will take those predetermined, those existing mate connectors that you've created and will automatically begin to attach them to different points in your assembly. What this means is you can take the insert process, inserting a part and mating a part, and you can take that from 2 steps to 1. And again, it sounds like I'm just eliminating 1 step, but this is something that people do all day, every day. So I turn on snap mode, That's step one, right? So I turn on snap mode, then I click insert just as I normally would, right? Then I browse to any part that has any, defined mate connectors. And what will happen is as I'm moving my cursor around, you'll see that same mate connector behavior. So it's going to take that attachment point that I've specified to the part, and it's going to give me the option to attach it anywhere I'd like, right? I can attach it to the end here, left click, and now that part is not only positioned, but mated with a fastened mate, right? And so it's easy for me to come in and say, okay, part 5 should go right here. Right now I have two parts in my assembly, both already mated into place. Okay. Another example I always like to show is a bolt to a hole. If you need to mate a bolt to a hole, you can do something similar to this, where I'm attaching, in fact, I'm missing a piece here. Let me try this again. I'm inserting my end caps. Okay, so we'll insert the end cap here, and again, insert the end cap here. Then what we'll do is insert our seal retainer, right? Same process, just left clicking and placing. Now, let's say that I wanted to insert a bolt, and this is another great example of this. Think of any kind of hardware that's attached to your assembly that you find yourself constantly having to manually mate each time. Here, I've created a bolt in this Part Studio, and I've added a mate connector right where the bolt head attaches to its hole. That makes it really easy for me to come in and say, okay, here's a bolt in a hole, and let's place it in this hole, for instance. So now I place the bolt in the hole, it's automatically fastened, so one step rather than two. And it's easy for me to select another bolt, place it into another hole, and I just keep going. And especially for stuff like hardware and things like that, where you're really just trying to attach it, you take it down from 2 steps to 1. Again, sounds like something very simple, but it can really make a big difference if you find yourself doing this a lot. Now, this is a separate discussion, but we're going to talk about patterns in just a second. I think patterns are very underused as well at the assembly level, at the part level, even at the sketch level. But I do want to stress, again, snap mode, the ability to define a custom mate connector, and really just understanding mate connectors can go a long way to simplifying and speeding up assembly design. So again, just the tip, understanding mate connectors. If you're still using that approach of combinations of faces and so on to mate your parts in position, of course it will work in Onshape, but it's not the fastest approach. And you'll find yourself you're doing it slower than someone else that's adopted these kinds of techniques. All right, so I see a few questions. Bear with me. When will sheet metal modeling be introduced to Onshape? Very, very, very soon. I can't give you a date. As always, we don't give out dates, but I will say that we are very, very close. I can't stress very enough. So I realize it's not the answer and everyone wants a date, but just realize we're hard at work on it and we're very, very close. All right, so would you mind showing us an example of in context? We actually have a whole separate webinar on Thursday on in context. I can mention this later on, but I do want to point out, if you're interested in the new in context functionality, we're doing an hour-long webinar on Thursday. Definitely sign up for that one. Next question. What's the best way to establish a group? Should I build it in the assembly and unmate it, or is it best to sketch them all in one place and import it into an assembly? You can absolutely sketch it all in one place and bring that all in as one piece and group it together. Absolutely. It's entirely up to you. I think that a lot of it is user preference. But building everything at one Part Studio, even off of one sketch even, is definitely an advantageous technique. Next one. What happens if the part added has 2 mate connectors? You can tab between them. You have the option to tab. Would it be possible to automatically name a mate feature using the 2-part names with an and between them? There is not a way to do that today. If you think that would be a helpful thing, definitely use the feedback tool and let us know. But I don't think you can automatically rename the mates. There's any way to do that today. Is there a way to select multiple mate connectors, then select the bolt part to add all the bolts at once? No, but bear with me for a second. I will show you something that does something very, very similar. So you're not referencing the mate connector, you're actually referencing a single mated part. I'll show you an example of this in a second. Do I have it right that you can't connect the mates in a Part Studio? No, You do not create mates in a part studio. There's no dynamic motion in a part studio. You can't grab a part and drag it, for example. Will you ever introduce using planes to constrain a component in an assembly studio? I'm not aware of an existing plan to add that, but I will say that I would never say never. So if that's a big priority for you, let us know. I know that that's not on the really near term, but again, that's all based on user feedback. What do you recommend for CAM? Anything that you'd like. There's a lot of CAM apps in the App Store if you haven't checked them out. So definitely check out the App Store. There's a lot of supported CAM apps that work well with Onshape. Okay, so this is snap mode. Really, my point is just understanding mate connectors. They have a big benefit, not just to snapping in like I was discussing a second ago, but even just the technique of attaching 2 points together is a much faster approach than using combinations of faces. You can still design that way. You can still assemble that way, but it's not a fast approach, and it's a tedious one when you get the hang of mate connectors. Oh, forgive me, I missed a question. I don't find history in Onshape anymore, only versions. So I can't jump back to one certain modification like before. Has it been recalled from free plan users? The answer is no. History is just incorporated into versions. So if I click versions, I go to show changes, I see the history. Okay, this is your history, and you can go to any point in it and restore. So again, history is not a separate button anymore. It used to be. Now it's under versions. You'll see manage versions in history. And to see the history, you just click show changes. And that will give you a list. You can show more changes and keep going. But again, your history is there under versions. Where can I post user feedback? Under the question mark menu. So under the question mark menu in the top right, you'll see feedback. Definitely use it. Report any bugs, any things you think we think should be at a priority. We really encourage you to give us any feedback that you'd like. Question. I created a spring and tried to insert it into an assembly round pin, but the mate connector wouldn't recognize the center of the helix. How can you mate a helix centered on a pin? And the answer is to create a custom mate connector in the spring. So you can create a custom mate connector using almost anything as a reference. If you have a helix, you probably have some kind of a circle or cylindrical shape, and you could probably use the center of that. But you can create a mate connector in the spring and then reference that mate connector when assembling. And that's another example where you're not just using faces or whatever it may be. You're actually using an attachment point. So a good example, good question. All right, so moving on. My next tip. So that was tip number 4, mate connectors, just right, reinforcing Onshape's different approach. And again, if you're using the old school techniques, you have the ability to really save yourself a lot of time if you understand these. All right, so moving on, patterns, and more patterns. This is something that's definitely underused, and it's something that a lot of users will find either the hard way or find after they've done lots and lots of tedious work. So it's just a reminder that you have lots of pattern options. So the question earlier, is there a way to select multiple mate connectors and pattern all my bolts in one place? And the answer is yes, you can do that with replicate. The questions often get asked, is there a way to do a pattern around a cylinder, a pattern along an edge? And the answer is yes. We have linear and circular patterns. We have linear and circular patterns for sketches, features, parts, and assemblies. So you really do have the flexibility to choose anything that you like. We have curve patterns that was recently added, so you can pattern along a curve. We even have custom feature script patterns that allow you to do all kinds of things. Fill patterns to pattern a feature within a plate, for example. Point patterns allow you to pattern parts along points. So really just consider patterns. They give you better design intent, right? Because they better reflect what you're trying to do. But ultimately, they're just faster. It's faster than the tedious effort it takes to sketch things manually, and so on. Now, I don't have an example of all of these. We've actually done past webinars on patterns, so just do a search on our YouTube channel for patterns, and you'll find one of those webinars. But just, again, driving home, you have sketch patterns, linear and circular. You have feature patterns, linear and circular and curve patterns. You have part patterns at the Part Studio, Again, linear, circular, and curve. And you have assembly patterns, linear and circular. But one of my personal favorites is a command called replicate. And replicate, as the name implies, replicates your geometry, but it's really neat in the sense that it looks at surrounding faces or edges. Rather than using custom defined mate connectors or anything like that, it looks at the geometry and tries to detect similar edges, same geometry, and then replicate the geometry there. So I'm going to give you an example of that one. Question, can a created hole be patterned in Onshape? Yeah, absolutely. You can pattern the whole feature just by selecting feature pattern and clicking on the whole feature in the feature list. So absolutely. Can you pattern a mate connector? Absolutely. Yes, you can. Let's move on to replicate. So let's jump into it. Now, this is one of my personal favorites when we talk about fast ways to assemble, and it's one of the commonly asked questions. It's not a linear pattern, it's not a circular pattern, but how do I create, something that is a pattern of geometry based on some feature? And the answer to that is replicate. So I can replicate. Right, I click replicate in the toolbar. I select my instances. Could be parts. In this case, it's a subassembly, and this work holding clamp that you see that's holding down this casting. So I'll select the work holding clamp as the parts or subassembly in this case that I want to pattern, and then I select a face to find matches in. And so essentially, if I click on the top face of this, it's going to look through this face and find the same edge in multiple places, and then it's going to pattern the subassembly to every single one of those places. It's important to keep in mind this is a bit different than a pattern in the sense that it's not dependent on the original. So I see a question: can I replicate and break any associations to the seed? It's replicating all of them plus the mates. So it's essentially as if you were to insert this subassembly over and over and over again and mate it into position. So you can see fastened one, all these different mates were created as a part of the replicate feature. So the replicate isn't a feature itself, it's just replicating the parts plus their mates. That means there's no associativity between them, right? They're not dependent on one another. It's not one big feature that controls everything. It's just a fast way to insert a lot of parts at once. Now, of course, this is a subassembly. If I were to change the subassembly, then, in all instances, update, but it's not a single feature in the feature list. So I can delete one, for instance, and not have the others. Okay? So a big tip, and this is, any of those scenarios where I'm inserting a dozen bolts, for example, and I have this same hole in all these different places, very common scenarios. It's easy for me to just take one example and replicate it to a whole bunch of places without having to manually mate each one myself, manually insert and then mate each one myself. So again, we have, of course, linear patterns, circular patterns at both the feature, part, and assembly level, sketch level as well. But we also have commands like replicate that can make a big difference in speeding up design, just common tasks. Are the parts fully constrained when replicated? Yeah, well, they're constrained using the same constraints that constrained the original. So in this example, my working clamp had freedom of motion. It needed to move up and down for the clamp motion. The same thing is respected in all the replicated instances of the subassembly. So it's just bringing over the mates from the subassembly. If all of those are fully constrained, then yes. But if those are free to move, then your replicated instances will also be free to move. So it's just replicating them. A very powerful command. Again, I think one underused, and I think I still see a lot of users out there manually mating parts into position when this could save them a lot of time. Okay? Is there one feature to rule them all? Unfortunately, no. Can I break that association so that each replicated part is different, similar parts but slight difference, like a family? You cannot. I cannot make this a different subassembly from here. I could create a new subassembly, but it's not separating it from the original. You can copy. It's not a true disassociation from the geometry. Where in this example, if I changed one, any of the clamps, because they're all the same, subassembly would update. I don't think that we have an easy way to break an association with and still keep all the geometry. Forgive me. I have to think about that one a bit more. Okay, in your example, how is the retention bolt head direction set? Retention bolt head direction set. Forgive me, if you're referring to the clamp arm, I'm not sure that you are, so forgive me if that's not right. It's not set. It's free floating. This clamp is free to swing in and out because that's what you would need to get the part in and out of the clamp. You could easily define it with a different mate that didn't allow it to rotate, and then I can set the exact angle by editing the mate connector. So just keep in mind, this is free to rotate, and it's free to move up and down and rotate. That's deliberate. That's because the design needs to be able to do that. But I can easily, in the subassembly, say, no, this should only move up and down, not spin, for example. Question, can components be mirrored within the assembly studio? No, there's not a mirror command at the assembly level. Part studio level, of course, but not the assembly. All right, so let's move on to the next tip in my list. As I mentioned before, again, patterns. If you think there might be a way to pattern the geometry, there probably is. Definitely do a search and find that command that you're looking for. There's patterns at the sketch level, feature level, part level, assembly level, and there's also things that are unique to Onshape, things like replicate that are definitely worth checking out. All right, so moving on to the next tip in the list, and that is dimension as you go. And this is something that a lot of users may not care for, but I think if you get the hang of it, it can really be a big advantage as you're sketching. And the idea behind it is, as you're sketching, you add dimensions. And instead of sketching everything first and then coming back and adding dimensions and having things scale, you have a really good idea right off the bat of the size of your geometry, and you've saved yourself a little time from coming back and having to dimension later. So a big tip, and this is something that a lot of users may not care for, but again, just driving home, it really can save you a lot of time, and that is just typing in a number as soon as you sketched a piece of sketch geometry. Line, circle, rectangle, ellipse, it doesn't really matter. Anything that you can apply a dimension to, you can dimension on the fly as you're sketching. So let me show you a quick example of this. This one's really easy to show, of course. So the idea behind it is, as you're sketching, you sketch any geometry, line, circle, doesn't really matter. As soon as you place it, and that's the key thing, you can't do anything else. As soon as you place it, you enter a number. So here, let's say I've got the line command up. I, start my line. Let's say I want a line here. As soon as I left click to establish that line, the second endpoint, you're going to see a number appear. I type, let's say 5, enter. Now I've added a dimension for that line, and I can keep going. So I can say, okay, 3, enter. And I can just keep moving, adding dimensions as I go, right? Now this may not necessarily reflect your design intent, and there's a different argument that can happen there. But again, just driving home, you can apply these dimensions on the fly as you're sketching. And now I don't have to, of course, come back and add those dimensions later. So this applies to more than just lines. It applies to things like circles. So if I add a circle, this is, I think, one of the more common scenarios. Circle, 10, enter. All right, now I've got a fully defined circle. Another example would be rectangle. Let's do a center rectangle. Center rectangle, left click to place. Let's say I want 12 by 10. Okay. It automatically jumps to the next number. In the example of rectangle, of course, there's 2 dimensions. It jumps to the next number for you. So another tip is you can use the tab key if you want to dimension one and not the other. And the same goes, by the way, for ellipse. Ellipse has 2 dimensions, of course, and the same process applies. But again, the main idea here is just that you're applying those dimensions on the fly as you're sketching, rather than sketching and then coming back later and doing it. All right, so moving on. Now, one bonus tip that I have, and this is one that I think it kind of ties into the sketching theme and a little bit ties into the dimensions as you go theme, and that is adding constraints. So bear with me for a second here. Let me jump over and show you a quick example of this. So adding constraints. This is something that we all do all day, every day inside of Onshape, and it can be one of those things you spend a lot of time on. So let me give you a quick example of how an average user might do it and one that's aware of a little trick. So I want to add tangent constraints between the line and the circle on all 4 of these. Right? So I need 4 different tangent constraints to fully define these lines relative to the circles. What an average user will do is they'll click line, circle, and then say, okay, I want tangent. And that's how, we all start. It's nothing wrong with this approach, I should say. But again, line, circle, tangent, right? And you can see line, circle, tangent. Now the icon does change, which is helpful. I don't have to go back through the dropdown, but you can see I'm doing this 4 different times: line, circle, command, line, circle, command. And so that workflow of, geometry, geometry, constraint, geometry, geometry, constraint. We've all done it, and you have to do it a lot. But there is an opportunity to save some time here. So instead of, I know in this example I need to add 4 tangent constraints. And rather than select the geometry first and then clicking the constraint, I'm going to click the constraint first, then click the geometry. So it's essentially the inverse order, but the beauty of this approach is the command remains active. So I can click tangent, line, circle, now they're tangent. Line, circle, now they're tangent. Line, circle, again, line, circle. I created 4 tangent constraints without having to go back to the command in the toolbar. Now, if you're a fan of keyboard shortcuts, you can use the T key, but even in that example, it's not remaining active. So just a tip, you can select the command first and then go in and add your constraints just by selecting geometry. That constraint will remain active until you go back and click on it or hit the escape key or one of those. So just a tip, you don't have to select the geometry first and then click the constraint. You can do the inverse, and when you do it that way, you can do it multiple times without having to go back to the command. And that can be a big one if you do, many of the same constraints over and over again. You don't have to click, go back to the toolbar every time. Okay? So that's kind of a bonus tip that I have for you there, somewhat tied into the dimensions we were talking about a second ago, but just realize you can click that constraint icon first. All right, so the final tip that I have for you, and I think this is the biggest one. If for heavy Onshape users, I'm sure you're going to be familiar with it, but I think for those new users out there, it has probably the biggest chance of making a huge difference in design time, and that is simply keyboard shortcuts. And this is something that if you're not already using, you should use more of. You should use and you should use more of. And the idea behind it is it just saves you a ton of mouse travel. And there's a lot of common keyboard shortcuts. I think everybody may use 1 or 2, but just realize that if you start to learn some of these keyboard shortcuts, you can make a world of difference when we start talking about just simple things. The example I always give is construction geometry. A lot of users aren't aware that you can click Q on your keyboard and turn anything into construction geometry, or vice versa. So very cool stuff. If you haven't checked out the keyboard shortcuts, I definitely recommend it. You'll find them under the Help menu. So under Help, you'll find keyboard shortcuts. Now, there are keyboard shortcuts for general purposes, like the docs page, for instance. Keyboard shortcuts for assemblies, keyboard shortcuts for part studios, for sketching, for drawings. Just realize that keyboard shortcuts for almost anything. One thing you can't do as of today is customize this list, but just keep in mind it is a very inclusive list. You've got a lot of things that you can do inside of keyboard shortcuts. So let me show you a quick example I like to do with this, just to highlight some of the things that you can do. So, for instance, I like the Shift S key to start a sketch. So I click a plane, Shift S, now I'm in a sketch. I use the N key for normal too. Right? So now I haven't touched the toolbar. I'll use the L key for a line. Right? We'll start sketching a line. At any point, I could define, okay, this is a construction line by clicking Q on the keyboard. Now I have a construction line. All right, I can go back and forth between solid and construction just by tapping that Q key. So another one is circle. I can click C on my keyboard. Now I have a circle. If I hit CQ, I have a construction circle. So again, just a big fan of keyboard shortcuts. They can really make a big difference in how you design day to day. Now, one that's particularly helpful, and if you're not a fan of keyboard shortcuts, I understand it. One that I think you should consider, even if you're not a fan of keyboard shortcuts, is the S key. The S key is what's referred to as the shortcut toolbar. And if you click S on your keyboard, you're going to see a small toolbar appear right at your cursor. And you have commands like line, rectangle, circles, arcs, splines, all the things you'd expect to find. And again, you don't have to go all the way up here to find them. It's going to appear wherever your cursor's at. So it's all about saving that time from mouse travel. So the S key is definitely one keyboard shortcut that I would recommend. Now, another one that I want to point out, and this was a question that was asked just a moment ago, can you window select? And the answer is yes. I can absolutely window select geometry, right? So I can window select these two instances or these two entities, for example, and hit Q and convert them to construction, right? Or I can select everything here, for instance, and hit Q and convert it to solid. So you can window select, and if you're familiar with the left-right logic of window selecting, that is supported in Onshape as well. Okay. Question: it would be good to have a feature to have clamp radial orientation be perpendicular to closed tangent surface. Forgive me, I'm not sure I follow. It'd be good feature to have the clamp radial orientation perpendicular to the closest tangent surface. Forgive me, I would need to see an example to understand that one. Is there any way to prevent the auto scale on the placement of the first dimension? No. Is there any preference of feature a face pattern over sketch pattern or the other way around? I will say that there is something of a matter of preference when we talk about patterns. So, a lot of users will say, I like sketch patterns, so I do all my sketch fillets at the sketch level, not the feature level. To some degree, it is a matter of preference. There is some big benefits of features over sketches, for example, when we talk about regeneration and patterns and things like that. But in general, I would say patterning a feature is a good technique. Face patterns are more specific and only for certain types of geometry, but feature patterns work almost anywhere. Sketch patterns, I don't know that there's a preference sketch pattern over feature. A lot of times it just depends on the geometry and the exact scenario. Can dimensions on the fly be used on the iPad app? I do not believe so. I think the answer to that's going to be no. Will you introduce polyline in Sketch Studio like all AutoCAD has? Forgive me, I'm not familiar with the polyline command specifically. If it's similar to our spline, no, you'd have to forgive me. It's very similar to our spline, but it's not the same, and I can see the difference. So I'm not aware of a specific plan to add that. If it's a high priority for you, let us know in the feedback tool. We do, of course, have a spline command, but I realize it's not exactly the same as that polyline. Can you add angles to dimensions on the fly? No, because angles involve two things. That's the limitation of dimensions as you go. And the idea behind it isn't necessarily to fully define everything. It's just to add dimensions for things like size of geometry. You still will need to add other dimensions, of course, to really properly define your intent. Can you window select? Yes. Can you print out the keyboard shortcuts, which is, I believe, what you're referring to? And the answer is yes. A tip with keyboard shortcuts, if you go to the help menu, you click keyboard shortcuts, there's a little bitty arrow icon in the top right. If you click that, it will launch it into a separate web page, essentially, a new browser page. And you can print this. I can right-click and print. I can put this on a separate monitor if I chose to. So it all depends on how I wanted to view it. But yes, you can print the keyboard shortcuts. You can also put them on a separate monitor if you choose to. That's all up to you. And again, you'll find that little tiny arrow in the top right corner. That's how you expand out that list. Question: what is an easy way to find what constraint is causing an error? Well, it's going to highlight in red. So those are going to be your biggest clues. Conflicting constraints will be in red. Can I create macros, maybe a feature script to do some of these shortcut macros? You can create feature script, of course, and feature script has a lot of overlap with macro functionality. So you can create a custom feature using feature script, very similar to the way you can create a custom feature using macros. It will not. It's not going to combine a common set of commands like a traditional SolidWorks like macro would. So there isn't an easy way to tie together a few keyboard shortcuts in this step plus a feature script to do it. Feature script is only about creating a CAD feature. It doesn't allow you to do things like, call up pieces of the interface, for example, or do those kinds of things. So it's really specific. So I'm going to say the answer to that is going to be no. Question: I read somewhere that use of key commands over mousing saves 2 years of time for the same amount of work for CAD designers over professional lifetime. That's a good point, and that's something that I wanted to mention with this. None of these are huge, shocking ways to save lots of time. It's more about the little things that you can do, that you do a lot of, and trying to save a few seconds here and there every 5 minutes, and that adds up over time. Okay. All right, so I am going to, I see there are quite a few questions. I am going to finish things up here. This is what I had planned for you. I do want to save one last slide. So this is my personal favorite list of keyboard shortcuts. I did forget N from this list. I think that's another popular one. But I think these, if you're going to learn some, are definitely a good place to start, especially for part modeling. L for line. C for circle, those are obvious. Q for construction, that's another very big one, very common one. D for dimension, T for tangent, S for the shortcut toolbar that I was showing you a second ago, Shift S to start a sketch, I for coincident, another common constraint. So these are just some of my personal favorites. Again, go to the help menu, go click keyboard shortcuts, and find the complete list. Another favorite that I have, I mentioned earlier, is the N key for normal 2. Everyone's going to have their own preferences, but definitely check out the keyboard shortcuts. They can make a huge difference in the design time, the day-to-day stuff, clicking commands and so on, which again, small improvements make a big difference when we talk about doing them over and over and over again. All right, so that is what I had planned for you. I am going to stick around and answer any questions. So I know there are quite a few questions that I haven't answered, so bear with me. I have one more question for the audience. Is anyone interested in either a private discussion or demonstration of Onshape? And we can get into more detail about how Onshape works in your scenario, how Onshape might apply to what you're doing. So if you're interested in talking with one of our account managers, discussing more specifically how Onshape applies to what you're doing, let us know, and we can have one of our account managers reach out. I am going to stick around and answer any questions. So make sure to get your questions into the questions section of GoToWebinar. But that's it, everyone. Thank you, and have a good day.